Duality property. Simple but confusing. Simply, it said that if you have a signal as a function of time, but it looks like what? It looks like Fourier transform another function, so you can get it by getting the x lowercase, replace t by negative omega, multiply by 2 pi. Of course, nobody understands anything. Let's just take an example. If you have x of t equal to e to the minus 2t ut, and we ask about Fourier transform on this signal, we will say x of omega is equal to 1 over j omega plus 2. How we got that from the table? Which formula did we use? We used e to the power of negative bt ut has Fourier transform 1 over j omega plus b, and I use in this case b equal to 2. All right, so we know that, but now let's just say that the question was like that. Find Fourier transform for y of t, where y of t is equal 1 over j(t) plus 2. So what you observe, this is a signal function of time, signal in time domain, but it looks like the one we just got it here. It looks like Fourier transform another signal. So how can you find its Fourier transform? You can use integration, true, but you'll spend a long time till they get the answer. So when I use the duality, how you'll use it? Let me show you simple steps. If you follow, you will get it right. The first step, replace t by omega in the expression y of t. But I don't like to write y of t because maybe it become the problem for you using x of t, whatever. The function that you want to find, it's Fourier transform, replace t by omega. So you will have 1 over j omega plus 2. Second step, find the inverse of what you got, 1 over j omega plus 2. Well, we know from the table 1 over j omega plus b give me e minus bt, which will be this one. We know that. So that will be equal to e to the minus 2t ut. So that will be your x of t, the corresponding one. 3, replace t by negative omega in the expression you got from the inverse. So I'll say e to the negative of 2 and t replaced by negative omega, that will be equal to e to omega u negative omega. Last step, multiply by 2 pi, and that will be the final answer. That will be the Fourier transform of the function given will be 2 pi e to the power of 2 omega u negative omega. Observe this all function of omega, it's a Fourier transform. So that's simply, so let's just make it short. When you want to find Fourier transform of a signal in time domain which looks like Fourier transform of another signal, you follow these steps. Let's have another example to make sure that you got it. Another example. Find Fourier transform for y of t equal sinc t over pi. So you got to think first, are you going to use duality or not? Because you got to ask the question, when can you use duality, or when you will not be able to use duality. Use duality if the function that you try to find, its Fourier transform, it looks like Fourier transform of another signal. I know that the pulse, rectangular pulse, b tau, it gives tau sinc omega tau over 2 pi. And if you only want to find sinc, so you can divide both by tau. So you will have Fourier transform of 1 over tau times the rectangular pulse equal to sinc, because tau, we can take tau here, sinc omega tau over 2 pi. So you know from the table, that's from the table. This one from the table. You didn't do anything with the problem yet. It's just you're looking at the table to see something similar to this one. So you say, okay, they are similar. They are similar. So what you're supposed to do? You follow the steps. Step number 1. Take this and replace every t by omega. So you have sinc omega by pi. What the second step? Do you remember? Find the inverse. Okay, the inverse is here. The inverse of sinc. This thing is equal 1 over tau with tau. But you don't know the tau in here. You don't know the tau in this one. So what you're supposed to do is just make a small comparison here. You will say this one, omega over pi is equal omega tau over 2 pi, and see what's the value for tau. That's easy. So omega over pi equal to omega tau over 2 pi. Omega was omega, so 1 equal tau over 2, so tau is equal to, that's it. So tau is equal to. Great. So what is the inverse of this one? Remember, this is 2. And that's 2. And that's 2. So the inverse of this one, it's the same as this one when tau is equal to. So just to write the inverse is equal to 1 over tau, which is 1 over 2, rectangular pulse of which 2. That's the inverse. All right. So next, replace t by negative omega. The last step, multiply by 2 pi. That will give you y of omega. 2 cancel 2, so it's equal pi, rectangular pulse of negative omega. And you should be able to sketch it and also express it mathematically, because this is a rectangle pulse with omega, not with time domain. I have to remember that. So the rectangular pulse of negative omega means reflected, so but just it's symmetric, so it doesn't matter. It will be look like that. And 2, the width is 2, so you have negative 1 to 1. The height is pi. That's y of omega. So y of omega, it's a rectangular pulse, and start from omega negative 1 to omega plus 1. So that will be the answer. I hope you got it.